Morning. My roll number is 19951A05N5. My name is N.V. Kaushik and I am from CSCD, and the subject is IoT. IoT Cloud Architecture and Implementation. Introduction. The Internet of Things, which is connecting the worlds, which is connecting the different parts of worlds, as you can see in the image. And the Internet of Things is a scenario in which objects, animals, or peoples are provided with unique identifiers and ability to transfer data over a network without requiring human to human or human to computer interaction. IoT has evolved from the convergence of wireless technologies, mechanical systems, and the internet. A thing in the Internet of Things can be a person with heart monitor implant, a farm animal with a Bishop transponder, and an automobile that has built-in sensors to alert the drivers when tire pressure is low, or any other natural or man-made object that can be assigned an IP address and provide with an ability to transfer data over a network. So far, the Internet of Things has been most closely associated with machine-to-machine M2M connections in manufacturing and power, oil, and gas utilities. Products built in M2M communication capabilities are often referred to be as smart. Introduction to cloud. There are many applications for cloud computing, like platform, infrastructure provider, service providers, and service clients. Okay. Yes. Cloud computing is typically defined as a type of computing that relies on sharing computing resources rather than having local services or personal devices to handle applications. In cloud computing, the word cloud, also phrased as the cloud, is used as a metaphor for the internet. So the phrase cloud computing means a type of internet-based computing, where different services such as servers, storage, and applications are delivered to an organization's computer and device through the internet. IoT reference architecture. It has web protocol, web and portal, dashboard, API management, event processing and analytics, aggregation, bus layer, ESB and message brokers, communications, MQTT, HTTP, and device manager, identify and access management. IoT architecture. It has many platforms and basically three building blocks, which are things, gateway, network, and cloud. IoT gateway. It has three separate steps, where Babylon Back, Raspberry Pi, and Intel Galileo. The heart of the cloud platform could use open source boards like Raspberry Pi, BeagleBone Black, and Intel Galileo, etc. There are usual Linux boards that run different flavors of Linux, like Raspbian on Raspberry Pi, Angstrom on BeagleBone, etc. These boards interfere with devices on the one hand and the cloud platform on the other. Cloud architecture is a way of technology components combined to build a cloud, in which resources are pooled through virtualization technology and shared across a network. The components of the cloud architecture include a front-end platform, the client or device used to access the cloud, back-end platform, servers or storage, cloud-based delivery mode, and a network. Together, these technologies create a cloud computing architecture on which applications can run, provide end users with the ability to leverage the power of cloud resources. Moving on, cloud architecture. It has many devices, as you can see, such as cars, vehicles, automobiles and mobiles, any type of connections like Wi-Fi, LAN, and many other connections which is passed through different processes like REST, APL, MQTT, COAP, customs, and through rules engine and storage, and the data is either pushed or pulled from the applications. And the Internet of Things has penetrated our lives in multiple ways. Some incarnations of these LOT systems are smart homes, connected cars, smart factories, and smart grids that consolidate, manage office data. In all these use cases, an LOT cloud structure is introduced when there is a need of process and analyze large data sets. The exceptional opportunities that cloud computing promises have encouraged organizations to seek implementations of this service in their business operations. However, the vast number of devices and conditions to be satisfied to make LOT work may be a determinant in many cases. This is where services of reliable full-stack LOT solution providers can prove to be invaluable. To achieve the expected results, the LOT cloud platform should robust, scalable, and agile with impeccable security features. The components of the cloud architecture should also work together seamlessly. Here we explore the various aspects of LOT cloud architecture with a special focus on the database design factors. Layers of cloud architectures for IoT. An IoT cloud architecture, the data flows across many layers. Although the actual cloud platform configuration may differ between organizations, all these solutions accomplish the same basic objective. This encompasses allowing different devices to connect to the network, processing the data, and utilizing the insights gained for automation. A significant part of the data processing takes place in the cloud databases and reporting layer. Let us take a look at the basic components of an IoT architecture. It has devices, several devices connected, like device N, device 4, device 2, device 1, through a stream of networks which is transferring the data from the service points 1, 2, 3, and 4 to the database. And it is also the middle part is being in the cloud, and the downstream consumer apps are being used to transfer the data through applications, mobile phones, web apps, and data links. Layers of cloud architecture for IoT. IoT devices. The devices integrate with sensors or accurates and establish a connection with the LOT integration middleware. In some uses, multiple devices may be grouped together and connected to a IoT gateway infrastructure that transmits devices data to the IoT integration middleware. These devices add drivers, software that enable access to the sensors, actuators. IoT integration middleware. The IoT integration middleware is an integration layer of various devices when connecting with the cloud. It receives data from the connected devices, processing it, and transmits the information to downstream applications. The process of data may include the evaluation of condition hashing rules and deployment of commands to the device sensors based on the evaluation. If the device supports a suitable communication technology like Wi-Fi or IP over Ethernet, a transport protocol such as MQTT or HTTP, and a computable payload format, it can transmit data directly to the integration middleware. Otherwise, an IoT gateway has to be installed in between for communications with the middleware platform. The middleware brokers also ensure that there is no loss of data, since asynchronous communications is established with the connected devices. Cloud servers. Servers are the most important part of LOT cloud, as these are needed to provide business services to customers. These are virtual machines linked to the individual databases. Based on the business requirements of the data storage and processing, SQL and non-SQL databases can be configured on the IoT cloud. Downstream applications, BI tools. The cloud servers are connected to the third-party apps, mobile web applications, or business intelligence tools through REST API endpoints. That's it all. Thank you.